So, hey guys, welcome to another video. Today we will be seeing the previous problem as well as the new problem. So, in the previous problem, we did the algorithm at first, which is not that much of clarity, so we did it wrong. Okay, and we have thought differently. It's like it was 180-degree apart, like we have thought differently. So now we have got something. Okay, you have to try. Then only you will understand the topic. It may be not like you haven't understood, but what we have done is that we have make 1 as 0 and 0 number of zeros is 0 and n we have taken. Okay, so I will show you. This is what it is we have done. This is the recursion tree which you have made, which we have made. If you know the we have to done this. Okay, what you have done? Just make number of zeros as the number of ones and one, and we have increased it numbers. Okay, we have not made it like n by 2, which is a very ambiguous. Like you don't know how many zeros are required. Like it is be less than, so we have to maintain that, not like n by 2 only. No, it is not like that. Okay, then we have make output made string answer, which where will be answer stored, and return answer, and one number of one zeros output and answer, and n we have taken and passed this by reference, passed also this by reference. Didn't need, but we have used it to as to minimize the space. Okay, because it is not changing. What is changing, we should pass by value. Okay, so what is the base case? So base case is when output becomes n. For example, n is 3, the output becomes 3 is the base case. Okay, is the base case. Okay, the base case is when it reaches the amount, like n equals to 4, then 4 things would be the size outputs. Then we just answer dot push back output. Okay, and if you see, one is added in each and every uh, steps, but there is some step where we are not putting it, is where 1 becomes n. So 1 is less than n, then we can make output 1 and we just put it. Pretty easy, not a very big deal. This line is very easy. Hypothesis which I have done only, and only recursion. Yeah, and if and zeros, we have conditions that when number of ones is more, number of 1 is more than what 0, number of 1 is more than 0, then only we have made the decision or made the choice of putting 0 in it. If it is equal, we will not put another 0 because zeros will be more. So when the one number is more, number of ones is more, then we just put a 0 to balance it out. Pretty simple. So that's how we solve this. Okay, so let us move on to the next problem. This is a Josephus problem where we have a Josephus, a guy was a Jew who with his 40 persons, he was one of them, Jew, in a cave surrounded by Romanian persons. So they decided to kill themselves before Romanian they do not want to surrender to Romanian. So so they decided a technique. Josephus told them to do this. Okay, so he the like 40% in the circle, and at 7% they just, okay, they have solved, and last person should do the on self. And Josephus did what he was at the place where he was the last person. So and at last he just betrayed them and just surrendered to what, our Roman. So that's what it is. So he knew, he is a mathematician, that this place would be the place where he will be the last person. Okay, so how to and we have to return the person's what, the person's, we can say, position. Let's say n equals to 3. There n equals to 3. The 3 persons rounding in a circle. Okay, first person, second person, third person. We first and second. Khatam, first, second, khatam. So third is our what? Is our output. You want to see? I'll show you. Which will not, which will be at last. You have to by himself. Okay. So this is pretty, what do you call? This is a problem we have to solve. If you see it, why it is a recursive problem. First of all, it depends, like, depends on the, like, the size is decreasing. Let's see, if the size is n, then it is n minus 1, one person is gone, then minus 2, and up at last one person will stay, and we have to return that. The best case is one person will stay. When the size is 1, then we have to, so we need a array or something which will be circularly, so modulo we will use. Okay, okay, and we need positions, let's say 1, 2, 3. Okay, three persons is there. Three persons are there. So the index here, 0th index, they have to do k person. Yeah, kth person, you can say 1, 2. Okay, so the index is 1, yeah, and k is 2. So we'll use k minus 1, that is 1. So x plus k, we have to erase that. Okay, we have to erase that. So now the reduce to 1 and 3. Then again we have to reduce to 1. Index index plus 1, that is 1 plus 1, that is 2, which is not in the boundary, so modulo size, that is 2. Okay, 2 by 2, 2 modulo 2 is 0. So here we come. Okay, and we have to this, and 1 is left, so we have to return that. Okay, you want to see, you can see this also. Okay, now to do this, we have to make a code. Yeah, let us write the code. to write the code. So what is the code? Hmm. Where is the code? We have the main function. Yeah, main function will have some n and k, n and k. Okay, n and k. N is the like three persons. So we will make a vector int with let's say, and we will uh, from obviously from uh, 1 to n, I think, because 1%, 2%, 3%, like this, like indexes is needed, like and third person. Okay, done this. So 1 to n, we have to vector push back. We can say push back I, well, or vector plus equal not vector pushback height. Okay, so we have made a vector with 1, 2 and 3. Yeah, now we will call the recursive function solve. We will have k for sure, that vector v, and we'll also have our what, k. Obviously we have to k minus 1, k equals to k minus 1. Okay, k equals to k minus 1. Okay, we need k minus 1, we need vector v, we need index. Now the solve function. Base case. You want to know the base case. Base case is that if if what, if v dot size equal to 1, v dot size is equal to 1, that means there is one element. There is one element, that is our answer. Okay, so we'll put answer also. Answer push vector of 0, that element, and return. If we put a return. Okay, now what do you do? Answer should be passed by reference only. Yeah, then what do you do? What we will do? Um we will have a base case done. Then we will have a um uh hypothesis. Oh yeah, hypothesis. IBH method. Okay. At first, minimizing it. Okay. So what person we have to do it? Just index equal I is index given plus k modulo n, that is size. V dot erase v dot begin plus that index. To get the index, you have got the index, then you have to erase that. You have erased that, so size is already minimized. So call the function kv index and answer, which will give us the minimized way. Okay, your speed is reduced. For example, 1 2, this is reduced. Okay, you have erased it. So vs 1 and 3. 1 and 3. Then again to see whether it is not, then index will be seen. um, index plus index equal index plus k. Because that index. Yeah. So this is the code. If you see nicely. So now we have written all these things: base case, hypothesis, main function, and erase all that things we have written. Now let us code it. We know all these things. What do we have to do? That we have int n. So let us make a vector, or we can say array. Okay, v. Yeah. Then for int I 1 less than equal to n, obviously. Okay, we have that indexes, and we need a sorry. Mm, we have k. We have we need let's light it lightweight. We need a answer where will be the element. Let's just have a guess. Now solve it. Solve. Okay, we need a vector v. We need a k for indexing. Index also. The index is 0. No, no. First index was 0. Okay. We need a answer. Should not be passed by reference, obviously. Index k passed by reference. Mm-hmm. Oh, k is also same, na? K is not changing. Why should I pass it by value? Index is changing though. Index is changing. Vector is changing. So if if v dot size equal to 1, the v dot size is equal to 1, that means we have found one element which is a valid, the smallest valid input. So we have to answer dot b of 0. Okay, the person will be here. Now return my hypothesis. What element we have to cross it? So index equal index plus k. Okay, modulo n p dot size, sorry. Hmm. Hmm. We have got the index v dot erase v dot begin plus index. Reduced all the functions, solve v index I, which is now changed. K is not obviously changed, it will not change. And so erase get element. We do not have to do anything, like induction process is not there because we do not have to add anything. We just have to place please solve. Hope you like this video, and I will be solving more questions on recursion. I will be starting a backtracking also. Hope you like this video. Like the video, comment, share, subscribe, and uh, this is for this video, and